We may start now. Yeah.
Okay. So, on behalf of Government Polytechnic Hamirpur and on behalf of this team, I take this opportunity to extend a warm welcome to Dr. Srinivas KG, Professor, Dean Academics, and Head of the Department Data Science and Artificial Intelligence, Triple IIT, Naya Raipur, Chhattisgarh, India. Sir, uh, first of all, a warm welcome to you for this faculty development program, and you will be our first keynote speaker in this inaugural session. So, your topic, I take the liberty in announcing Introduction to IoT and Machine Learning. So, from here now, I'll be handing the
So
platform.
good evening, everybody, and so it was really nice to see my good old student, a distinguished student, Dr. Mr. Pankaj Thakur, who was very active since he was a master's student, and he was very deep enthusiastic in conducting such kind of events, and especially conducting such kind of events in a government system, especially at a polytechnic level, is not easy, but he has taken a lot of pain and pleasure and pressure to conduct such kind of events. So nice. And unfortunately he has made me as the first speaker, so it is a big problem in the sense the first impression will be the best impression, or it will be the last impression. So therefore I should be more careful in handling this session, because you may actually have to keep this impression for the whole week. So the title is IoT and machine learning in the context of smart cities. As one of the distinguished audience has already told, the issues related to the city like Bangalore that they are facing. So there are two things. One is, what is this IoT and machine learning? So they are actually nowadays concepts. Actually, if you see nowadays, these two concepts are coming even to the school level. If you, I don't know how many of you are aware, there are a lot of adult tinkering labs that has been established in majority of the schools, and they're actually teaching these robotics, IoT, AI, machine learning at the school level. So therefore, we may have to actually understand these kind of things in a very different perspective. See, one is understand now what I told you. Now IoT and machine learning, they are no more the tools. Sorry, they are no more the concepts. They are like tools. And what is the application that we are talking about is the smart city application. What is the smart city? Somebody has told the objective of the smart city. So it is not, the objective of the smart city is not to facilitate all the people who are having luxurious cars to drive in a very hassle-free manner in a city. Actually, the objective of the smart city is to make even the richest person to commute through the public transport. So that is actually the objective. We have to make the system in such a way, the smart cities should be made in such a way that the public transport, public utilities are to be actually even enjoyed by the richest person. That is what the smart city. For example, if you go to Singapore or some places, actually people love to go in metro. Okay, they love to actually use these public utilities because they are so convincing and they are so convenient. So you have to make cities in such a way that So smart city is not to just give the luxury. The smart cities is to make the cities sustainable. The smart cities are to decrease the carbon emission. The smart cities have to play a key role in the water reservation, avoiding air pollution, then emission of carbon, and many such kind of things. So, don't always have an impression that smart cities are only for making traffic free, what you say, kind of very luxurious cities. It is not like that. It is to make cities sustainable, and it is to make cities more awarding and rewarding with respect to their nature. So in this context, we have to, because the IoT and ML is just one kind of use cases which can be actually applied in these contexts. So we will just have, so before I go, I will actually um, I will share this with Pankaj, these PPTs. This set of PPTs I will share. I don't use I am not actually, I will share it. I am not asking people to what you say, read my book. These are some of the slides that are actually taken from a book that I have written long back, maybe almost 2008, 7 or 8, almost 8 years back. This book was written on Internet of Things. Unfortunately, it is out of print. Okay, so but I will give this what you say, the ideas, sorry, the PPTs to Pankaj, the whole, all the PPTs of all the chapters, so that you can go through and learn. So I will just go through the other slide. Yeah. So what is this Internet of Things? What is the evolution, standards, and challenges? This we will just check with respect to the smart cities. So now, as you know, why IoT? Because we have seen the evolution of internet. There is a very good human progression. We have, I think, people who are in the edge of 50, they have seen uh, time from no telephone to a very nice Apple iPhone. Okay. So such kind of, especially people who are in the age of 40 to 50, have seen this such a fast progression in technology. And the web has gone through several distinct evolutionary stages. Now, actually, let me tell you frankly, there is, you cannot live without, majority of the population now cannot live without World Wide Web or internet. So if you recall, the stage one of the World Wide Web was only the research phase. That was ARPANET was actually given. It was primarily used by academia for research purpose. Whereas stage two was something like a brochure war or domain name or gold rush. Almost every company wanted to share the information about their products and services to their web pages. There was a .com outburst in 2000 and it went on so well. Then slowly the web moved from a static data to a transactional information. Like the products and services could be brought and sold, and services could be delivered, like eBay, Amazon, Make My Trip. There are so many such kind of e-commerce websites came onto the scene, and there was a .com boom and bust. Now the stage four is the social or the experiential web, where the social medias like Facebook, Twitter, LinkedIn, and so on are actually playing a very pivotal role and allowing people to communicate, connect, and share the information, like abundant of information on text, photos, videos about themselves with their friends, families, colleagues. There's a lot of things happening, in the social this one. Okay. So now we are at this stage of internet. Now, coming to human progression, individual data by itself is not very useful. Let me tell you, only if you say some data, it is of no, but the volumes of data when it comes in volumes, you can identify some trends and patterns. So, when we used to teach the first course on data mining, we used to give an example. So, what is the example? The first association rule mining algorithm was actually implemented. It identified a very peculiar pattern or the trend. See, what is that peculiar pattern? Usually, for example, if somebody purchase bread with jam or a pickle, it is very common, obvious. So people cannot eat bread alone, so they have to eat with jam or a pickle. But they found in a Walmart data, transactional data, every Friday, they found a very peculiar pattern that people who used to uh, 80 sorry 60% of the people are the transactions where people used to buy nappies for kids. They also used to buy the beer. So it was a very peculiar transaction. So actually in a so now nobody knows why how can a nappy is related to beer. So later they found out the story goes like this. Like in US, every evening, what Friday usually what happens, Saturday, Sunday, it is the job of the husbands to take care of the kids. So usually what the husbands do is they take nappies for their kids, and also they used to put them in the playground, and they used to enjoy the Saturday, Sunday with the beer. So that's why this only on Fridays the nappies used to get transacted along with beer. So this is what they found, it seems. So therefore, when you have a very huge volumes of data, you can identify a very unnatural trends and patterns. And IoT dramatically increases the amount of data available for us to process. So this is coupled with the internet's ability to communicate this data, and this will also enable the people to advance further. And we combine the ability of the next evolution of the internet IoT to sense, collect, transmit, analyze, and distribute data on a massive scale with the way the people process the information. Okay, so what we do is we allow humanity to have knowledge, and then slowly see, always there is a this is the hierarchy. Data, from data, then data type, then database, then information to knowledge, knowledge to wisdom. So this is the hierarchy: data, data type, database, information, knowledge, and wisdom. So now what we are trying to do, we allow the humanity to have knowledge and develop the wisdom. It needs not only to survive for, but to better utilize the resources. So now please try to understand what is IoT. It is a world's wise network. Don't say it is worldwide network. It is really a wise network of interconnected computer networks based on standard communication protocols. Thing is, it is an object that is not precisely identifiable. Then IoT means it is a worldwide network of interconnected objects which are uniquely addressable based on some standard communication protocol. Okay. So now, while the current internet is in a collection of rather uniform devices, IoT will exhibit much higher level of heterogeneity because devices are completely heterogeneous. Okay. and the objects are totally of different functionality. You have a mobile, you have a sensor, you have a camera, you have a car or something like that. There are different technology and application fields will belong to the same communication environment. So in 2008, the number of devices connected to the internet exceeded the number of people on the earth. So it was told by 2020 there will be around 50 billion devices there. It was told in 2020. So IoT is one of the 6 civil technologies with potential to enhance or degrade the US power by next 15 years. That was told by National Intelligence Council. Similarly, the computers are now disappearing into a fabric of everyday life. Now people cannot, now every mobile is actually computing gadget. Okay. So the Gartner told IoT installed base will grow to 26 billion units by 2020. So this was, so let me tell you the Gartner's chart. This is always very interesting. I think I should tell you about this Gartner's chart. I will present that 1 minute. Yeah. So there is something called Gartner hype cycle. So if you see the Gartner's hype cycle 2024, this is the emerging Gartner's hype cycle for emerging technologies. So this is the Gartner hype cycle. And if you see, hope you are seeing this. I don't know how many of you. Okay. This is the kind of thing. See, please see what is in the hype. There are actually something. Those who are in the hollow box, they will be reaching the scope. This is actually what happens. Any technology, when it starts coming in research field, to go to the plateau of productivity, in the sense when you actually start actually producing industrial things from them, it is called plateau of productivity. Actually when you start producing products based on such technologies, so that is a plateau of productivity. See, for example, here it was told there is nothing like GitOps. GitOps. It is a very famous this one GitOps. Now also it is used. It was told it is told in 2024. It will take another 2 years to reach the plateau of productivity. Similarly, those who are in this orange cycle, 2 to 5 years, that is disinformation security, then AI TRISM, then prompt engineering. Please see, it is already it has come to this one. Then internal developer platform, then web assembly, generative AI. This will take around 2 to 5 years to come to plateau of productivity. Similarly, the others like 5 to 10 years, like reinforcement learning, artificial general intelligence, then federated machine learnings, homographic encryption, super apps. So these are all humanoids. Okay, they will take another 10 years to come to plot of productivity. So like that, these are the 4 emerging technology trends that the Gartner has told. So that is autonomous AI, developer productivity, and deliver human-centric security. So this is like that. There are a lot of hype cycles. So this is the Gartner hype cycle of emerging technologies. So there are 4. One is autonomous AI, then total experience and human. So this is what is actually you can go through this website. It is very interesting and it will tell you, it will predict all the futuristic technologies. So every year the Gartner will publish the hype cycle of emerging technologies, and based on that, actually the whole industry will work. Okay, so this is a very interesting thing. So let me go back. So it was told like in 2011 itself, it was predicted that around the connect in the 2003, the connected devices per person was 0.08, but in 2010 it becomes 1.84 per person, the connected devices. In 2020 it reached to what, 6.58 connected devices per person. That is the kind of this one. Okay, then so what are the technological trends? So it is possible to identify 5 distinct macro trends, not micro, macro trends, that will shape the future of IT, together with the explosion of ubiquitous. Why ubiquitous? Because they're all moving, they are not static. Okay, ubiquitous devices that constitute the future of IoT. So one is called data deluge. That is, uh, there is lot of data, explosion of the amount of data collected and exchanged. So it forecasts indicate that in the year 2015, more than 220 exabytes of data will be stored. It was told, now it has actually crossed this. Novel mechanism to find, fetch, and transmit the data will be needed. Similarly, decrease in the energy required to operate intelligent devices. Here, the search will be for a zero level of entropy, where the device or the system will have to harvest its own energy. So now people are talking about the batteries which will energize by itself. Okay. Then miniaturization of devices. As you see, the devices are becoming micro device, nano, micro, nano, millimeters. The devices are actually becoming increasingly smaller. You can't even see the devices in your naked eyes. Then autonomic management, that is, the devices or the systems will have self management, self healing, and self configuration capabilities. Okay. So now the history of IoT, if you please see, if you go back, it dates back to early 80s, when the first appliance, that is called a Coke machine. In 2008, the Coke machine was actually at Carnegie Mellon University, was connected to internet to check its inventory to determine how many drinks are available. Okay. So now, what is the conceptual framework of the IoT? One has to understand. Please see, it will be an integrated part of the future internet. It will be a dynamic global network infrastructure. Self-configuring capabilities will be there based on the standards and interoperable communication protocols. Physical and virtual things are seamlessly integrated into information networks. Then smart things or objects are expected to be active uh, participants in business, information, and social processes. Okay. This is a very important, I always see how the things work are changing over the years. If you see this graph, in 2010, only around 10% of the devices are used for heating, air conditioning, and control systems. Another 10% was white and household goods. For example, chair, table, and other things. Okay. And less than 10%, around 5% was entertainment and media. There was only one, what you say, a big audio system or something. And rest all, around 80% was computer network equipments. Okay. That was the connectable devices. Now, if you please see in 2020, so almost 30% is heating, air conditioning, and control systems. And you now for every computer you will get a better chair, table, ergonomics related. So you spend almost 30% for white and household. Then intermediate you have something earpod. There are so many things. Entertainment and media equipment will be another, and there are only around 20% will be computer network equipments. Everything is wireless. Okay. So this is the kind of dramatic change that has happened in last 10 years. Okay. So now when you talk about the IoT and the smart environment, how it works, everything wants to be smart. You want the smart energy, that is, people talk smart buildings, smart living, smart transport, smart cities, smart health, everything. So let us see what are the new things to augment the life, like smart city. See, in a smart city, what is the objective? For example, you may have to reduce the traffic congestion, and you have to better use of resources, improve the security. Smart car, if you want, when you say that the car is smart, it should reduce emissions, it should increase safety and save fuel. When you say the home is smart, it should make entertainment more interactive and immersive. It should increase the comfort, save energy. When you say smart me healthcare, empower patients, help physicians to monitor and diagnose remotely. When you say smart me wellness, help to lead the healthier lives, optimize the sports performance, early warning of illness. Then smart industrial and smart devices, they give productivity gains, efficiency, agility, water, and food. So these are all very important things. What are the IoT enablers? Okay. One is called energy. The issues such as energy harvesting and low power chipsets are central to the development of IoT energy, especially energy harvesting, low power chipsets. These are all very important. Then intelligence. So this is what the machine learning will give you. The machine learning, IoT and machine learning, why they are interrelated? The intelligence to IoT is given by machine learning. The devices should have some capabilities such as context awareness and inter-machine communications, etc. And coming to communication, a new smart multi-frequency band antennas integrated on chip made of few materials or the communication means that they will enable the devices to communicate. Then integration of smart devices into packaging or better into the products themselves will allow a significant cost saving and increase the eco-friendliness of the products. And interoperability, the protocols for interoperability have to be standardized. The standards, open standards will be key enablers for the success of the IoT. Sustainable, fully global, energy efficient communication standards that are security and privacy centered and use compatible or identical protocols at different frequencies are needed. So what are the technologies for IoT? Please see, these are all from 2000 to 2020, how it has changed. Earlier, we had something called RFID tags. IoT started with this RFID tags. Okay. So which was used for facilitating routing, inventory, loss protection. This was this demand for expedited only for logistics. Then we had these devices came: surveillance cameras, security, healthcare, transport, food safety, document management. So this was mainly for vertical market application. Then we came to ubiquitous positioning. The GPS came into picture. The locating people and everyday objects. The GPS, geotag, other things. Ability of devices located indoor to receive geolocation signal. Now coming to the physical world web, where people are talking about teleoperation, telepresence, ability to monitor and control the distant objects with the advent of miniaturization, power efficient electronics, and available spectrum. So you have to get then similarly software agents and advanced sensor fusions. So now what are the technologies for IoT? IoT's realization depends on continuous technical innovation in a number of fields, from wireless sensors to nanotechnology. And the main technologies required in the areas of identification and addressability, then sensing, then embedded intelligence, and miniaturization. These are the main technology areas for IoT. First, one by one. What do you mean by identification and addressability mechanism? So, this is needed in order to connect everyday objects and devices. So, to large databases and networks, so that the data about the things can be collected and processed. So typically, an example is RFID offers the ID functionality like barcodes, 2D, 3D. There are so many things, not only RFID. And who will give the address for this? So the IPv6 provides sufficient address space for this. Then comes to sensing, to detect the changes in the physical status of the things using sensor technologies. Here, sensors play a pivotal role in bridging the gap between the physical and the virtual worlds, and it will enable the things to respond to changes in their physical environment. For example, sensors in an electronic jacket, they collect information about changes in external temperature, and the parameters of the jacket can be adjusted accordingly. Okay. Then embedded intelligence in the things themselves. You have to embed the intelligence in the things themselves. So to further enhance the power of the network by evolving the information processing capabilities to the edges of the network, then empower the things and devices at the edges of the network to take independent decisions. Okay, so these are all very important. Four things: identification and addressability mechanism, sensing, embedded intelligence, and okay. Then what are the characteristics of IoT? These are the five characteristics that will make IoT a unique. Okay. One is event-driven architecture, then ambient intelligence, complex system, semantic sharing, size, time, and space considerations. These are the five things. So what is an event-driven architecture? Likely to be an event-driven architecture based on the context of processes and operations. And event-driven architecture will be based on production, detection, consumption of, and reaction to the events. Now, what is an event? An event is an action that is usually initiated by the outside, which is actually outside the scope of the program, and that is handled by a piece of code inside the program. That is called event processing. Okay. So event-driven systems are typically used when there is some asynchronous external event activity needs to be handled by a program. So the whole IoT is basically an event driven architecture. Okay. Then comes to ambient intelligence. There, since the autonomous and intelligent entities, because they are interoperable, they are able to auto organize themselves, and they can act independently to pursue their own or shared objectives depending upon the context or the circumstances of the environment. And autonomous behavior is not the part of original concept of IOC, but what happened, the recent shift in the research to integrate the concept of IoT and autonomous control, now they want it, like now self-driving cars and other things, now they have a lot of ambient intelligence and they are autonomous self-driving cars. Okay. So autonomous control and IoT, they have increasing robustness, scalability and agility in the logistic networks. So it will be a very complex system. Again, IoT will be considered and studied as a complex system. Okay. Due to huge number of different links and interactions between the autonomous actors. See, in the sensing and actuators are the part of IoT. So therefore, we have a lot of autonomous actors and its capacity to integrate new actors. That is what a complex system. A system, because it is composed of interconnected parts, that as a whole exhibit one or more properties which is not obvious from the properties of the individual part. That is therefore it is very complex. Therefore, it is not something as easy as embedded system. Please try to understand. It is beyond embedded systems. Okay. So please see, the complex systems include the cascading failures. What are the characteristics of a complex system? The characteristics of a complex system include cascading failures. That is, if one fails, the other fails. Then difficulty in boundary determination, where actually what is the boundary of a particular sensor or an event or an objective. It is very difficult to find out the boundary. And it may also have some memory also. So therefore, sometimes the memory doesn't get refreshed. It may be nested. There may be a problem inside the problem, so it may be nested. And non-linear relationships, small change, large effect. Okay, it is called butterfly effect. Then there may be a lot of feedback loops in the interrelation. That is, element effects of an element's behavior are fed back in such a way that the element itself is altered. Okay. So, but in theory or the literature, lot of these complex systems models have been developed to solve such kind of complex systems, which include ant colonies, human economies and social structures, climate change, nervous systems, cells and living things, human beings. So these are all some of the models that have been developed. Then the whole IoT works on the concept of semantic interoperability. What do you mean by semantic interoperability? The IoT objects will be able to understand each other through something called semantic. What do you mean by semantic? Different stakeholders can access and interpret the data in an unambiguous way, which is very much required for an automated information and communication in IoT. And semantic annotation of data can provide machine interpretable descriptions, which include what the data represents, where it originates from, how it can be related to its surroundings, who is providing it, what are the quality, technical and non-technical attributes, and so on. Okay. So the size, time, and space considerations include IoT will encode almost 50 to 100 trillion objects and be able to follow the movement of those objects. And humans in a surveyed urban environments are each surrounded by 1,000 to 5,000 trackable objects. Okay. Then IoT will encompass billions of parallel and simultaneous events. So to tell you that time will no more be used as a common and linear dimensions, but will depend on each entity like object, process, information systems, and accordingly IoT will be based on massively parallel IT systems. Then coming to the space consideration, the precise geographic location of a thing will be critical. So therefore, the internet is primarily used to manage the information processed by the people. uh, the relevance of location information about a thing is decided by a human user. Okay. And we may have to search for the things based on the location instead of by a keyword only, what is here. And the virtual representation of the earth that is geo-referenced and connected to our digital knowledge archives. So the challenges remain variable spatial scales, massive amount of data, indexing fast search and neighbor operations. So now these are all some of the characteristics, try to understand. So now what comes is the architectural trends of IoT. So what are the issues that are important for IoT standardization? One is designing web services as a common platform to publish service definitions and exchange configuration information between various hosts. Designing messaging services layers, providing a basic web services messaging framework between the host, which abstract lower layers. Then designing common data exchange formats for sharing of structural data across different systems. Then using internet protocol layers or an IP proxy layer for connecting network nodes across multiple types of networking technologies, RFA forms, radio. Please try to understand how complex the architectural trend. When is you have somebody has to design a web service, somebody has to design a messaging service, somebody has to design common data exchange format, and people have to sync on the internet protocol that is being used. So the architectural framework needs to incorporate all these desired aspects such as scalability, flexibility, adaptability, etc. And the components and the interfaces for various building blocks such as devices, device interfaces, data formats, networking standards and protocols, service platforms, and application interfaces are to be defined in an IoT standards. Okay. So the need for sensor standards. What are the need for sensors? The sensors are already prevalent today, but they will become even more necessary and prevalent in IoT-enabled devices and applications. So you may be RFID readers, cameras, accelerometers, GPS thermometers, and so on. And the sensors are developed by a variety of manufacturers using many different protocols and formats. So therefore, making the interoperability and large scale sensor integrations required by the IoT will be difficult without any standards. Similarly, the effective use of sensors to enable and drive the IoT requires standards for discovering sensors, retrieving sensor data, tasking sensors, subscribing to, and receiving sensor alerts. So please see, these are all the role of sensors in IoT. Sensors are important for tagging, tracking, locating, and monitoring things. And for enabling things, we have to be aware of the environment around them. These sensors are the key enabler of IoT and foundational technology for many IoT building blocks and related technologies. For example, what are the enabling building blocks? These technologies like machine-to-machine interfaces and protocol of electronic communication, microcontrollers, wireless communication, RFID, energy harvesting technologies, sensors, actuators, location technology, and software. And similarly, there are synergetic technologies. These technologies may add value to IoT. One is geotagging, geocaching, biometrics, machine vision, robotics, augmented reality, mirror worlds, telepresence and adjustable autonomy, live recorders and personal black boxes, tangible user interfaces, clean technologies, and so on. So, the basic requirements of the sensor web. So, it will quickly discover the sensor and the sensor data. What is sensor web? It is nothing but the web of sensors. It is nothing but, see, it is another name for IoT. So, which will quickly discover the sensor and the sensor data and secure or public that can meet my needs like location, observables, quality, ability to task, and so on. They obtain the sensor information in a standard encoding that is understandable by me and my software. Readily access the sensor observations in a common manner or in a form of specific to my needs. Then task sensors, when possible to meet my specific needs. Then subscribe to and receive alerts when the sensor measures a particular phenomenon. This is an example of sensor web. Okay. These are web accessible sensor networks and archived sensor data that can be discovered and accessed using standard protocols and application program interfaces. So coming to what are the emergence of forms in IoT, a complex adaptive systems. It is a network of components with defined interfaces, self-organization, that is emergence of semi-stable structures, phase transition analogy, that is mix of fixed and changing. Then also there is something called CAS, activities, properties, that is as applied to distributed systems, um, could bring us closer to software architecture that could evolve as quickly as business processes are now. So, what are the emergent IoTs based on the location of objects? So, everything is related to everything else, but near things are more related than the distant things. So, therefore, location now it has become an excellent basis for prediction of the behavior. So, therefore, there is now actually a degree also started on geoinformatics. Okay, the location is an excellent basis for prediction of the behavior, and many companies use location as the basis for business. And end user applications will reap the benefits of ubiquitous information from IoT. The location advances for IoT will be geo SMS for objects, indoor positioning, indoor maps, indoor navigation, and so on. So there is something called OGC, Open Geo SMS Standard, which will give you the geotagged text messages a significant potential, okay, for emergency and disaster response and other applications. It is multilingual, it is multi-device, it is harmonized with existing applications, and it incorporates relevant ISO standards and so on. So before going to this, there are a lot of standardization efforts on IoT that is coming up. One is called CASAGARAS. It is called Coordination and Support Action for Global RFID related activities and standardization. So this includes standards and procedures for international standardization, regulatory issues with respect to RFID standards, global coding systems. Then these are all socio-economic components of RFID users. So similarly, the same thing model of IoT came into picture. Now the CASA GRAS had adopted inclusive model of IoT which embraces fully inclusive range of edge technologies, including RFID for interfacing with physical world, then exploiting the evolving object connected data capture technologies and network capabilities like sensory location and location communication and security, then exploiting existing and evolving communications and mobility structures, then integration with evolving internet and so on. So this is an example of architectural component. So like you have ID and additional item, then sensory and data carriers, network data, physical interface, lot of interrogator or gateway devices, then there are actuators, then there is a host information management system and a wide area or internet. So there is one more called IoT standardization effort in World Wide Web W3C consortium. World Wide Web Consortium. It is called World Wide Web Consortium, which is involved in the standardization efforts of IoT, which is a mix of rapidly evolving network technologies, Ethernet over TCP. These are all Wi-Fi, Bluetooth, Zigbee, cellular packet radio, a lot of things. But there are a lot of challenges to different addressing schemes in P2P networks. And security and privacy issues are also there in communication. Then device coordination is a big problem, and event transportation. These are all some of the IoT standardization efforts in World Wide Web. So before going to smart cities, let me show you one video.
Hello. Sir, you are not audible.
1 minute, 1 minute.
Okay, okay, okay.
I'm just sharing one video.
Today, automation is transforming our lives for the better and making our cities smarter. For example, automation enhances operational efficiency by providing real-time analysis of traffic flow, crowd occupancy, and queue length to people on their mobile devices and suggests the best routes to follow, easing further crowd gathering. Automation also ensures safety by enabling video-based smoke and fire detection for outdoors and high-ceiling environments, leading to faster response times in fighting fires. These are just some of the use cases that automation is revolutionizing that require manual intervention. One of the key benefits of automation is the ability to significantly cut costs and response times to make our lives easier. Omniscient is a global leader in AI-based video analytics, providing real-world solutions to address over 300 smart city use cases. With advanced capabilities such as multisensory analytics involving video, sound, and smell, Omniscient smart solutions crunch varied forms of data in real time to keep cities safe. Keep cities moving smoothly. and enhance the overall quality of life by improving public services and improve resource utilization. IQ Smart City from iOmniscient brings together this vast array of intelligent capabilities into a single comprehensive portfolio of capabilities. It empowers civic authorities to automate, track, and monitor a wide range of services, infrastructure, and environmental parameters. iOmniscient enables every single camera in the network to work as one large brain and carry out functions like tracking a person from camera to camera. iOmniscient's graffiti detection system can detect graffiti and identify the culprits who are responsible for these actions. This helps keep the neighborhood clean and saves costs on repainting buildings. IQ Smart City can detect accidents and areas that get congested and provide an analysis of the timing of these events. This can be used to reduce congestion at peak times, as well as reduce pollution and make cities more sustainable. The platform's Finding of Lost Children system ensures full privacy protection for the public, even while it enables the identification and tracking of suspects or criminals in crowded, uncontrolled environments like railway stations, airports, parks, and more. This helps prevent bomb threats, robberies, and other crimes, and adds another layer of security to the city, making it safer for all. IQ Smart City slashes response time by 80% by automatically locating the nearest appropriate responder and telling them where to go and what to do, whether it's a road accident, disaster response, or pandemic response. IQ Smart City harnesses Intel, One API, and the Intel distribution of OpenVINO Toolkit to speed up deep learning inference at the edge. The platform's Super Edge device is deployed using the 2nd and 3rd Gen Intel Xeon scalable processors, and the IQ server systems leverage Intel Core i7 and i9 processors for enhanced analytics. With projects implemented in 70 countries around the world, the technology has been proven to be robust. It is computing light by design and minimizes the cost of cameras, storage, network bandwidth, and computing infrastructure requirements. With intelligent edge solutions built on the IQ Smart City platform and powered by Intel, citizens are safer and healthier.
Yeah, I will show you one more video. Just give me 1 second. It is just an example of how smart cities in USA look like.
As urban populations around the world continue to rise, demands on city infrastructures, services, and the environment are increasing at an alarming rate. Fast-growing, future-focused cities like San Jose, California, are leading the way in harnessing the power of the Internet of Things and smart technologies to help them manage their sustainability challenges while creating new clean economy jobs and improving livability for their citizens.
San Jose's Green Vision is our roadmap to being the clean tech innovation center of the world. We face some pretty big challenges. The Smart Cities project will help us have the data to answer the questions of how we can be more efficient, more effective. We need the data in order to understand where the bottlenecks are, where the problems are, and where we can do things to improve the quality of life for our people.
The United States needs to take a leadership role in smart city implementations because it reduces our dependency on fossil fuels, defines a more sustainable urban environment, and as we see our population grow, it's important that we are at the forefront of shaping that direction. The best way to change behavior is to provide real-time feedback. And the Internet of Things is that opportunity to our residents and businesses. The Internet of Things represents three important aspects for the city of San Jose. It's driving a strong local economy, it is enhancing the quality of life of our residents and businesses, and it increases participation in government.
One of the things we've learned with the implementation of our San Jose Green Vision is the importance of public-private partnerships. Our partnership with Intel will help us generate the data we need to make good decisions to be more effective, more efficient with the resources we have.
Following an implementation strategy designed to minimize burdens on city resources, San Jose has successfully deployed a new sensor network for monitoring regional air quality. It's projected that the Green Vision initiatives will ultimately create thousands of new clean tech jobs in the region as they scale out smart solutions for traffic, climate, public safety, and beyond.
What I'm really excited about is Intel technology allows us to connect to the Internet of Things, which enables us to secure real-time data. The platform we've deployed with the Intel sensors provide us the opportunity to look at water quality, sound, temperature, and a variety of other elements that make a difference to the quality of life of our residents. Real-time data from Intel sensors provide us the opportunity to shift from reactive to proactive.
Drawing on embedded systems already in place and powered by Intel, along with a network of new sensors, Intel technology delivers practical, cutting-edge intelligence about noise pollution, traffic flow, and air quality. Improvements in these systems promise to transform everyday life in U.S. cities and around the world.
We need to be smarter, we need to be more effective, we need to be more efficient. Smart Cities USA project will help us do that.
Yeah, now we will go back to our presentation. This is just one example of how the smart cities in rest of the things that is working, so that we will understand. So we will just see what are the IEEE standards on smart cities. So please see, there are a lot of initiatives from IEEE on smart cities, especially with respect to seamless connectivity. Like there is a new 802 initiatives which gives high efficiency WLAN. For example, for something like a point of sight in stadium, location services, consumer variables, enhanced video, and so on. So the 830 standards for smart cities include intelligent transportation, that is represented by IEEE 802.11p, which supports communication between the vehicles and the roadside and between the vehicles while operating at the speed of maximum of 200 kilometers per hour. And the communication ranges up to 1000 meters in a 5 gigahertz band. Similarly, there is an IEEE 61609 family of standards for wireless access in vehicular environments, that is also supported by IEEE. Similarly, there is a IEEE smart grid and digital energy management, which comes under power line communication, that is IEEE 1901 series. In that also there are certain variants, like IEEE 2030 series works on smart grid including electric vehicle infrastructure, IEEE 1547 series on handling distributed resources in electric power systems, IEEE 1815 series works on electric power communications, and so on. Similarly, there is a smart home series, like you have home networking standards from IEEE 802 to 1815, then smart grid to home devices standards, then smart metering standards, then 3D video standards, mobile video standards, home networking standards, electric vehicle standards, and many such kind of things. So there is a smart home. The IEEE has developed standards for smart home. So coming to an end, there are a lot of challenges like standards harmonization. Multiple sensors and IoT standards need to be harmonized in order to realize the interoperability and across the sensor systems. Similarly, in the big data, the sensors and IoT add to the growing amount of monitoring data that is available to a wide range of users. So how do we effectively analyze all these data and ensure that the meaningful and relevant data and the decisions are made? So big data and IoT are actually they come each along with each other. Okay, there are some examples in India also. In Mumbai, there is a tale of two cities. For example, the poorest people of Mumbai pay 37 times more for water. So Dharavi, the poorest neighborhood in Mumbai, the municipal grade water is almost $1.12 per cubic meter. There is a Warden Road, which is a better side of the city, just blocks away. It is 0.03 per cubic meter. So what is that? The source of disparity is the higher cost of delivering the utility services to poor neighbors because of infrastructure inefficiencies, problems such as leaks and left. So therefore, Mumbai Corporation has adopted IoT mechanism to overcome this problem. Then there is an IoT application. A lot of ubiquitous sensors and connected systems will provide authorities more information. Okay. Okay. And this will allow utilities to operate more profitably, giving them extra incentive to giving them extra incentive to improve the infrastructure in the poorer neighborhoods, and more efficiency will also allow the lower prices, okay, which in turn will encourage those talking services for free to become paying customers. So a lot of applications from manufacturing, logistics, retail sectors, okay, then supply chain, as the Gati Shakti project of Government of India is completely dependent on it. Energy and utility sectors like smart electricity, water transmission grids, real-time monitoring, intelligent transport systems, environmental monitoring systems, home management and monitoring systems, okay, and lot of such things. So to concluding, IoT is at the stage where disparate networks and multiple sensors must come together and interoperate under a common set of standards. And IoT will gain acceptance among the general populace, service providers, and others must deliver the applications that bring tangible values to the people they use. Okay. So IoT must not represent the achievement of technology for the sake. It should demonstrate the value in human terms. Okay. So I think with this, I will, because we have around 10 to 15 minutes. I will spend my time for some interaction because it should not be only laborious. Yeah. Any questions, please? I think we have another 10, 15 minutes. Yeah. See, the other the other part is the other part is machine learning. I did not touch much upon machine learning. The machine learning basically provides intelligence. Yeah, please. Swapna, madam, please.
Please, the participants are requested to please raise a hand, then we will come up to you. Okay.
So the other part I did not actually touch upon is the machine learning. Please see, there are two parts, AI and machine learning. AI is more work on strategies. Like if you want to play a chess with the computer uses the AI. Whereas the machine learning basically applied on the rich data. So now as you see, the IoT generates a lot of data. So now if you don't use this data, then it is of no use. So intelligence, the systems become intelligence through the mixture of IoT and machine learning. Okay. So without these two, you cannot actually separate. They are inseparable. IoT and machine learning are inseparable. You have to get the data from the IoT systems and you have to apply the machine learning algorithms and derive some intelligence, and again send that intelligence back to the customer so that they use it. Okay, so then the whole cycle or the loop gets closed, and people talk these as cyber physical systems also, because it closes the loop. So IoT generates data, machine learning uses the data, generates the intelligence, and again that intelligence will be shared back to people, so that, see, for example, the traffic data is get generated. So you take all the traffic data, the machine learning algorithm takes all the traffic data, and it will it will actually give you where people have to take alternative routes, and that alternative routes will be actually sent back to the people, so that they can actually use that information to avoid any more congestion. So that is how the loop will be closed. Okay, so therefore it comes together, IoT and machine learning, so they are not inseparable. And there are a lot of techniques in machine learning which is actually not the part of this course of study, so therefore I did not touch upon that. So there is one question: data from IoT devices are large volumes of machine can only help us to clean. So can we use information to apply to use cases? Yeah. These are all very, see, the IoT generates a lot of data. This data may be in the edge devices or it may be on the cloud. So the machine learning is applied either at the edge device. Edge means at the lower level, maybe at the edge level or at the cloud level. Then the derived information can be again sent back to customers, and this is definitely used in many use cases. Okay, lot of use cases exist for this. Any questions?
Hello, sir.
Yeah, please.
Sir, this is Dr. Rohit Kumar Das. First of all, I'd like to thank you for giving such a wonderful information on this IoT and machine learning and all. I would like to ask you one question: is the importance of simulation and test bed implementation to integrate this different kind of application scenario altogether. So, as we prefer researcher, simulation first and then test bed implementation. But sometimes it used to get platform dependencies and all. So there are lots of challenges that we faces. So can you please put your point of view on how
Yeah,
to
see,
implement this further?
this anywhere if you want to work on a hardware platform, people first prefer simulation. But typical Indian researcher will stop its research at the simulation itself.
Yes, sir.
See, the problem is it is not because they don't want to do, it is lack of fund, lack of infrastructure, and many other things. See, for example, I don't know, if you want to do something, work on agricultural IoT. See, definitely instead of doing a simulation, I think you can consult a farmer who is having 1 or 2 acres of land. Go there, apply embed some small sensors which are embedded with Raspberry Pi or somewhere. You put there, collect the real data, apply, give the real information back to the farmer. So this becomes a good case study. A problem is, I don't know whether this becomes a publishable article or not. Unfortunately, to publish an article, you may have to raise your bar beyond the research which is already done. But if you want to reach to the reality, you may not be able to do in such a, see, for example, you cannot really work on 1 lakh sensors. You don't have it. You have to actually approach some test beds that are already been there, or you have to go to simulation. But you can work on 5 to 10 sensors that can be easily deployed in a place. So it is only the matter of scale and the amount that you can spend. Okay, but if you want to get your papers published in a high impact factor journal, then you may have to do an extensive simulation with a very good mathematical modeling and all. Otherwise, you may have to go for case studies. Okay, hope my answer is convincing.
Yes, sir. I have published in IEEE IoT journal multiple times, with where I had to integrate both simulation and test bed both. But yeah, the problem that we basically faced is this scaling one. where the reviewer generally asks that no, you can't justify your answer with only 50 notes or 100 notes. So again, yeah, theoretical model comparison has to be again given in that.
This is the problem, especially in a case of IoT. When you want to scale, you may have to actually tie up with some of the standard test beds or benchmarking test beds that are right now available for public use in some universities, where you may have to send your things and they may apply. So that is a very lengthy procedure to book their test bed also, but it may not be in all cases. Okay, I don't know your exact area of research in IoT, but it is very difficult when it comes to scaling.
Yes, yes. Okay.
But when it comes to use cases, you have a lot of use cases, especially in Indian scenario.
Yes, sir. Thank you so much,
Instead
sir.
of now after some time, you have to switch from IEEE Internet of Things journal to MBA case journal. Okay, so there is a case journal. I don't know how many of you know, where you can actually publish cases. Okay,
We'll look into that, sir. We'll look into that.
okay. So
Thank you so
people,
much.
okay, thank you. Any other question?
Thank you, sir.
Thank you.
We were so glad to have you on board, since you have worked as professor at very prestigious institute, and plus you are a senior member of IEEE and ACM, plus you have been conferred with Young Achievers Award and various fellowships like Boycast, etc. Thank you so much. And the session was, I think, very informative.
There are
And
last two questions I will just answer.
yes, sir, definitely.
What
You
are
can
the
take on.
views of academics to IoT? Should it belong to computer science, electronic? Please, nowadays, this bar should be removed. It is not. It is for everybody. So now people cannot work in competition or in isolation. People have to work in coordination and cooperation. So remove this bar of computer science, electronics, electrical. So computer science is more like a use case, and if electronics, electrical people don't use these tools to make their system smart, they also don't have any it is a question of their survivability. So therefore it is all together, it is all inclusive, it is not exclusive or separated. Then what are the upcoming research topics in IoT domain? There are edge analytics and many other things. I don't want to go much in detail. There are a lot of such kind of things. Yeah, madam, thank you. So thank you for giving me the opportunity. I think you have last 5 minutes left for the next session.
Thanks, sir.
Thank you.
The session was indeed very informative. Before starting the next session, there is a poll in the Google Meet. So you're requested to participate in that.
Yeah, good. Okay, then I will leave this session. Thank you.